A pleasant day to each and everyone. Welcome to our channel. I am Naslin B. Avila and I am willing to help and guide you throughout our discussion. So for this lecture, we are going to discuss adding and subtracting polynomials. However, I highly suggest that you watch first the video tutorial on constant, variables, and algebraic expressions, which was also discussed in this channel as a means for you to relate more to the content of our discussion for today. Once again, this video tutorial is all about adding and subtracting polynomials. And in this lesson, let us challenge ourselves to attain the following learning outcomes. So the first learning outcome is add and subtract polynomials. And the second learning outcome, solve problems involving real-life situations using addition and subtraction of polynomials. So before we move forward to our formal discussion, let us first have our pre-activity. So this is entitled Sort It Out. This will help us recollect and review some of the basic and important concepts that we will be using later on with our discussion. Now to start our activity, from the pool of polynomials, you are tasked to group all like or similar terms in the box. So I will be giving you at least 10 to 15 seconds to answer our pre-activity. This is just a recap, so I suppose that you already have the basic knowledge on how you are going to group all similar terms or like terms in the given box in the left side. So time is up. I suppose that you are already done answering our pre-activity. Now let us check if our answers are correct. Let us first have our first box. So what is in the first box? We have negative 10x, negative x, and negative 3x. Now question, are there other polynomials or expressions in the pool that wasn't included in the box? So let us check. Do we see any expression with the variable x other than these three? So there is none. Therefore, our first box is complete and is correct. Now what about the second box? What is inside the second box? We have x squared plus 2y, negative x squared plus y, 4x squared plus 2y, and 5x squared plus y. Again, question, are there any polynomials or expression in the pool that wasn't included in the box? So let us try to check if we can see other expressions which have a variable x squared and y. Do we see any of this? No. Therefore, our second box is complete and correct. So let us now move forward to our third box. So what are the polynomials that is inside the third box? We have x plus b and negative 5x plus b. Again, question, are there other polynomials or expression in the pool that wasn't included in the box? So let us try to check. So there is none. Therefore, our third box is complete and correct. How about the fourth box? What are the polynomials written in the fourth box? So we have 6cy, cy, and negative 5cy. Again, are there other polynomials or expressions in the pool that wasn't included in the box? So do we see other polynomials with the same variables included in the fourth box? There is none. Therefore, our fourth box is complete and correct. Let us now proceed to our fifth box. So in our fifth box, we have 10x plus 5y plus 3, and the second polynomial is x minus y plus 6. So if you notice, we have three terms. We have 10x, 5x plus 3. And the second polynomial, we also have three terms. And we have the same variables. Therefore, since we do not see any other polynomials or expressions in the pool that wasn't included in the box, our fifth box is complete and correct. And now, if we notice from the pool of polynomials, we are now only left with 10xy and negative xy. And these two have the same variables, which is raised to the same power. So therefore, we can group these two and we can write this in the sixth box. So therefore, in the sixth box, we have 10xy and negative xy. Now, from the answers that we have obtained, our prior knowledge has been reiterated that like terms are terms that contain identical variables and exponents regardless of their coefficient. So how do you find our activity? Were you able to group all similar terms together? If not, then you still need more practice before you can proceed to the next lesson, which is about simplifying polynomials. But if yes, then you are now ready for the next lesson. Now, before we can proceed to our proper discussion, let us first have a proper recap into Introduction to Polynomials. Now, what is a polynomial? A polynomial is made up of different terms that contain positive integer powers of the variables. So here is an example of polynomial. We have 5x cubed plus 3x squared minus 2x plus 1. And each part of the polynomial that is added or subtracted is what we called a term of the polynomial. So in this example, 5x cubed, 3x squared, negative 2x plus 1 is what we called the term of the polynomials. And in this example, we have 4 terms. And the number appearing in each term in front of the variable are what we call coefficient. And in this case, 5, 3, and negative 2 is what we call coefficients. And the number appearing all by itself without the variable is what we called a constant. And in this case, 1 is the constant. Again, in this given polynomial, the coefficient of x cubed is 5, the coefficient of x squared is 3, and the coefficient of x is negative 2, and the constant is 1. It is also important to remember that a polynomial in one variable is written in descending powers of the variable if the exponent on the variable decrease from left to right. So in this case, we have 5x cubed plus 3x squared minus 2x plus 1. The powers of x are decreasing from left to right. We can think of this polynomial as 5x cubed plus 3x squared minus 2x raised to 1 plus 1x raised to 0. As you can see, the powers of x are decreasing from left to right. We have 3, 2, 1, and 0. And if you are still confused about what is polynomials, you can watch the video I have suggested for you to watch. And now to start our proper discussion, let us start with simplifying polynomials. Now in simplifying polynomials, remember that when you add similar things, the result will always be similar to the things you added. This concept is also applied in adding polynomials. Let us try to study the problems given below. So the first problem, we have 10 apples plus 22 apples, that is equals to 32 apples. In the second problem, we have 3 million plus 2 million, and that is equals to 5 million. And for the last problem, we have 12xy plus 3xy, that is equals to 15xy. Notice that the results were similar to the things being added. When you combine apple with an apple, the answer is also apple. This is also applied when adding polynomials. You can only add terms that are similar to each other, like in the third example, we have 12xy and 3xy. Both expressions are polynomials and are similar. Thus, their sum has the same literal coefficient of xy. Remember that a polynomial is simplified if it has no terms that are alike. Like terms are terms in the polynomial that have the same variables with the same exponents, whether they have the same or different coefficients. I hope that this is already clear to you, so we are now going to move forward to our proper discussion, which is all about finding the sum and difference of polynomials. But first, we are going to discuss on how to find the sum of polynomials. So how can we add polynomials? The addition of polynomials is simple. While adding polynomials, we simply add the like terms. Therefore, it is important to remember the rules of addition of polynomials. The first rule is to remove the brackets. The second rule, organize the terms by writing them in descending order by degree with the constant as the last term. The third rule is combine like terms, and the fourth rule is to add the coefficients of like terms while keeping the variable the same. Like terms have the same variable and exponent. Now, adding polynomials consists of two ways. The first way is horizontal way of adding. And in horizontal way of adding, we have 3 steps to follow. The first step is write the polynomials in a horizontal manner with an addition sign between them. The second step is combine the like terms together by clubbing them in parentheses by retaining the sign of every term. The third step is perform the calculations. The second way of adding polynomial is what we call the vertical way of adding. And in this, we also have steps to follow. The first step is write the polynomials in standard form, which means we have to write it in descending order. The second step is place the polynomials in a vertical arrangement with the like terms placed one above the other in both the polynomials. The third step is if any power term is missing in any polynomial, we write as 0 as its coefficient to avoid confusion in the column-wise arrangement. And the last step is to perform the calculations by retaining the sign of the terms. So let us further explain these two ways of adding polynomials through an example. Following the horizontal way of adding, we are going to solve our example number 1. Determine the sum of negative 3xy plus 2yz plus negative xy plus 4yz. Following this step, we are first going to write the polynomials in a horizontal manner with an addition sign between them. So we will have negative 3xy plus negative xy plus 2yz plus 4yz. Next step is we are going to combine the like terms together by clubbing them in parentheses by retaining the sign of every term. Therefore, we will have the quantity of negative 3xy plus negative xy plus the quantity of 2yz plus 4yz. Next is we are going to perform the calculations. And therefore, we will have negative 4xy plus 6yz. And this is now our final answer. Let us now try to check if we can derive the same answer using the vertical way of adding. Using the same example, we are going to determine the sum of negative 3xy plus 2yz plus negative xy plus 4yz. Following this step, first is we are going to write the polynomials in standard form, which is we have to write it in descending order, and as we can notice, the given is already written in standard form. So therefore, proceed to step 2, which is to place the polynomials in a vertical arrangement with the like terms placed one above the other in both of the polynomials. So we can rewrite the expression as negative 3xy plus 2yz plus negative xy plus 4yz. Since our step 3 is not applicable, we can just move to our step 4, which is to perform the calculations by retaining the sign of the terms. So therefore, negative 3xy plus negative xy retain the sign, that is equals to negative 4xy plus 2yz plus 4yz, and that is equals to positive 6yz. Therefore, our final answer, which is negative 4xy plus 6yz, is the same to the answer that we have derived using the horizontal way of adding. Let us have more examples. Again, using the horizontal way of adding, we are going to solve our example number 2. Determine the sum of 2a plus 4 and negative 3 plus 7a. Following the first step, we are going to write the polynomials in horizontal manner. So we will have the quantity of 2a plus 4 plus negative 3 plus 7a. And the second step is we are going to combine the like terms by clubbing them in parentheses and retain the sign of every term. So we will have the quantity of 2a plus 7a plus the constant term, which is 4 minus 3. And the last step is perform the calculations, and that is equals to 9a plus 1. Therefore, our final answer is 9a plus 1. Let us try to check our answer using the vertical way of adding. Now, using the vertical way of adding, we are going to solve our problem number 2 or example number 2. First, as we are going to write the polynomials in standard form, and as we can notice, the polynomials is already written in a standard form or in its descending order. So we can proceed to our step 2, which is to place the polynomials in a vertical arrangement. So we can have, first as we are going to write 2a plus 4, and the like terms will be placed one above the other in both of the polynomials. So the second polynomial is negative 3 plus 7a. Since 7a have the same term or the same variable with 2a, so we are going to write 7a below 2a and negative 3 below 4. So we will have plus 7a minus 3. Since our step 3 is not applicable in this case, we are going to proceed to our step 4, which is to perform the calculations by retaining the sign of the terms. Now 2a plus 7a is equals to 9a, and 4 plus negative 3 is equals to positive 1. Therefore, our final answer, 9a plus 1, is equal to the answer we derived a while ago using the horizontal way of adding. Let us have more example. Let us try to solve our example number 3 using the horizontal way of adding first. So we have to find the sum of x squared plus 2x plus 3 and 2x squared plus 7x minus 2. Following the step, we are going to write the polynomials in horizontal manner with an addition sign between them. So we are just going to write the polynomial x squared plus 2x plus 3 plus the addition symbol plus the other polynomial, which is 2x squared plus 7x minus 2. And then proceed to step 2. We are going to combine the like terms together by clubbing them in parentheses. So x squared plus 2x squared, we can pair that to plus 2x plus 7x plus the quantity of the constant 3 minus 2. Since we have already grouped the like terms together, we are going to proceed to our step 3, which is to perform the calculations. So x squared plus 2x squared is equals to 3x squared, and 2x plus 7x is equals to 9x, and 3 minus 2 is equals to 1. Therefore, our final answer is equals to 3x squared plus 9x plus 1. Now let us try to solve this problem number 3 using the vertical way of adding. First, as we are going to write the polynomials in standard form, and as we can notice, it is already written in standard form where the power is written in decreasing order from left to right. So we can proceed to our step 2, which is to place the polynomials in a vertical arrangement. So first, we are going to write the expression x squared plus 2x plus 3, and below this is we are going to write the second expressions. However, we have to take note that the like terms shall be placed one above the other in both of the polynomials. So we are going to write 2x squared below x squared and 7x below 2x and negative 2 below the constant term 3, and we are going to add these two polynomials. Since the step 3 is not applicable again in this case, we are going to proceed to our step 4, which is to perform the calculations by retaining the sign of the term. Now x squared plus 2x, that is equals to 3x squared, and 2x plus 7x, that is equals to 9x, and 3 plus negative 2, that is equals to positive 1. Therefore, our final answer, 3x squared plus 9x plus 1, is the same with the answer we have derived a while ago using the horizontal way of adding. So that is all for finding the sum of the polynomials. A different link will be provided for the second part of this video, which is about finding the difference of the polynomials for your convenience. Thank you, and please stay tuned.